So this is the second part of the multiple objective linear programming model. And in the first lecture, we were able to create a mathematical model from this problem. And so now we're going to implement the model. So I'm going to use Excel to create the model. So here we have a company, ABC, and we know that this company operates in two centers. So we have center A, and also we have center B. So these are the centers. We can say it's ore mines. And the company has months to operate. And so every month the company can add one more shift. And so let's see months to operate. And in this case, it is a decision that should be made how many months the company will operate. And so we can highlight this and define this as our changing variables or changing variable cells. And then we remember when we did goal analysis, we focus on the target values. And so in this case, we're going to look at the goals as well. And so we have one goal, which is to reduce the cost per month. Also, the company is planning to reduce the toxic water or gallons, we'll say, per month. And then the other one was to reduce accidents per month. And so in this case, if we know that going to with the original information, the cost per month for A is $40, and the toxic for A was 800, and also accident per month was 0.2, and cost per month for in project 2, if you can remember, it was $32, and then 1,250 gallons of toxic water, and accident per month 0.45. And so we can look for we can find the total, and so we're going to find the total for all this, but we have the target value. So we'll define target values here, and we're going to do exactly the same as in goal analysis. And so here we will look at the percentage deviation, and then if you can remember, we had weight. And so for weight, each of these goals was given weight, and so we can just put that one as we give them 1. We don't have indifferent in this case. And so the target value also is given. This is the one that we had to find. And if you can remember, we had the target value for the cost of production to be $244, and then which is the minimum that can be used, and also the minimum toxic water gallons we found to be 6,950, and also we found the minimum accidents, which is the target, to be 2. But here we could also find the weighted average deviation. So let me write here, weighted percentage deviation. So the next thing, we are going to look at the constraints. And with the constraints, we have high grade call, we have medium grade, and also we have the low grade. Those are the constraints which we were given. And if you can remember, we had 12 for A, that's high grade, and also 4 and 10 for low grade. And so we have four four center B, and then we have also 4, and we have 20. We can look at the availability, and then we'll look at the required. And we remember we had information on the required. Here, the high grade that is required is 48, and 28 is the medium grade required, and the low grade was 100. And finally, we are going to look at the objective. And so we are going to use minimax variable. And let's choose this as our, let's define it. And so this for now is considered as set cell and also variable cell. So that is set cell and variable cell as well. So after defining this, we can go back now to find the total. And in this case, we're looking at the total for the cost per month, toxic water, and also the number of accidents. But this total will base on the months to operate. So for now, we will put just zeros there. And so to find the total per month, we are going to put equal sign, and all we have to look for is this times the cost per the months to operate. And so we can use the sum product. And this sum product will be cost per month, and then put the comma sign, and then you can highlight this. And because we're going to copy the formula all the way down, then we need to lock this down so it can be applied to the toxic water per month and also for the accidents per month. And in that case, we have to put the dollar sign to lock this down. And remember, if you're using Windows, you can click on F4 and you will be able to put the dollar sign. And if you're using Mac, you can press function and F4. Then that will create the dollar sign. And that's what I just did with my Mac. And so all you have to do is put the dollar sign to E. You see, this is cell D15 and the E15. And so for the E15, we need to put the dollar sign. So I'm going to press function and the F key on my Mac computer. But also, if you're using Windows, you just click on F4. But it is important for you to just put the dollar sign in between this variable. So in this case, now we can actually enter and we can copy the formula way down. And you can see we have zeros because we are not operating it yet. So if you operate for 4 months, you could see this will change. And so let me just make it 0 for now. So we have found the total of all this. Now the next thing to do is to find the percentage deviation. In the first lecture, we defined the formula for the percentage deviation, which was the actual value minus the target value divided by the target value. And so we're going to apply that formula here. We have the total, which is the actual value, minus the target value divided by the target value. So let's work for the cost per month. We can put equal sign to create the function. And so we're going to take, we can use the brackets. And so we'll take the cost per month. Now it's 0, but it's going to change depending on the months to operate, minus the target value, and close the bracket. We're going to divide it by the target value. So I will click this one again. And in this case, we can enter, sorry, let me repeat again. So we're going to put equal sign as our function, and we'll take the total cost per month minus the target value. I'm going to use the bracket and then divide by the target value. And so I will enter. So you can see that, so we can copy this formula all the way down. But now we're using the dollar sign here. We don't really need to use the dollar sign because we don't have the dollar sign in this case. Okay, so I will change this just to be the numbers. And so to find weighted percentage deviation, we will take the percentage deviation times the weight. So I'll put equal sign, and then we'll take the percentage deviation times weight, and so that will give us the weighted percentage deviation, and then we can copy it all the way down. And so we are done with that. And the next is to find the objective, which is minimax variable. So before the minimax variable, we need to find the availability. And so availability will be the same as what we did here. We are looking at the availability based of the months to operate. And remember here, we look at the cost per month times the months to operate, toxic water per month times the month to operate, and so forth. So the same will apply here. We could create the formula, or we can copy the formula from here. Just copy and paste that formula. And so you can see it is the sum product of D24 and E24, the comma sign, and then D15 and E15. But this one is locked. If you double click here, you can see the months to operate are given dollar signs. And so it is the same formula which we applied there. We can copy it and apply it here. So you can click and you can drag down to use the same formula for medium grade and the low grade. So next we are going to do the minimax, or we're going to find the objective, and we'll put 0 there for now. But the minimax or the objective function will be the set cell and variable cell. So remember here we said is a set and variable cell. So we are all set to put this in Excel, and therefore we can use solver. So click on the data, and then you can go to solver. And with solver, we need to find the set objective. Remember, our set objective in this case is this set here. Now you can see that we didn't create any function or for this objective or the set cell, but we are going to use it, to apply it as the variable cell. and therefore that will be our objective. So let's proceed. Now we need to not to maximize, but we're going to minimize, because we are minimizing the cost, toxic, and accidents. And we can do so by changing some cells, which are actually the changing variable cells. And we have already indicated them here. So we'll select this. But now we need to select the objective as our variable cell. And so in that case, I'm using Mac, and so it's a little challenging here, but you can put the comma sign and click on the objective. So you may have some challenges when you click another variable cell. The first one may go, but if you face that problem, please let me know. If you're using Windows, it's not a problem. Just put the comma sign and select this, meaning that your variable cells are the months to operate and also the objective. And so we can go back, and now we can add the constraints. In our previous lecture, we say that the weighted percentage deviation should be less or equal to Q. So in that case, it should be less or equal to this cell here. So that's our constraint. And therefore, I will select all this weighted percentage deviation, and they should be less or equal to Q. And the Q is this one. And then we can add. So we are going to look at the total. The total, where's the total here? You can see that the total should be more than the target value. So the total values should be greater or equal to the target values. That is the second constraint. We can also add more. Let's add the months to operate, and that's the non-negativity constraints. So months to operate, let me select all this. They should be greater or equal to 0, non-negativity condition. And I think that's all. We can click OK. Make sure unconstrained variables are non-negative. So by checking this, we are not using GRG, but we are using simplex LP, and we are done. So we can solve. So you can see Solver found a solution for me that all constraints and optimality conditions are satisfied. I'm going to keep the solution and wait to see what you guys got.